Dear learners, welcome to NIOS Studio. I am Ekta, PGT Chemistry. Today we are going to discuss about lesson 23, Nomenclature and General Principles. You will be able to understand at the end of this unit, you will be able to understand the concept of reaction mechanism, electron displacement in covalent bond, and you will be able to understand the concept of types of reactions. Let us understand the concept of reaction mechanism. The general reaction is depicted as follows. An organic molecule is attacked by attacking reagent to form intermediate which result into the formation of product. So, if you look at the definition, what is reaction mechanism? It is a sequential account of each step describing details of electron movement, energetics during bond cleavage and bond formation, and the rates of transformation of reactants into products. The kinetics involved in it is referred to as reaction mechanism. Breaking of covalent types of bond. A covalent bond, there are two types, homolytic fission and heterolytic fission. The fission of covalent bond with equal sharing of bonding electron is known as homolytic fission, whereas heterolytic fission, there is unequal sharing of bonding electrons, is known as heterolytic fission. So, when you look hypothetically the molecule A and B, these radicals are called as free radical, whereas in case of heterolytic fission, one of the atom occupies negative charge which is called as carbanion, and the other atom occupies positive charge which is called as carbocation. So, here is, you can see how the fission takes place. Next is the homolytic fission result into the formation of free radicals which are neutral species, whereas in case of heterolytic fission, carbonium obtained by the heterolytic fission initiate the chemical deficit rich neutral species. Breaking of covalent bond takes place by the attack of electrophile or nucleophile. Thus, molecule on some of the carbon atom, this polarity can be developed by the displacement of bonding electrons due to certain effects. Electronic effects may be permanent, like in the substrate molecule under the attack of reagent are known as electron displacement. Electronic effects, inductive effect, electromeric effect, resonance effect, and hyperconjugation. So, let us understand what is inductive effect. You can see in electronegatives, the shared electrons pair are attracted more towards the electronegative atom, hence there develops a polarity. So, the polarization is caused in the sigma bonded carbon atoms. Types of inductive effect, plus I effect and minus I effect. Plus I effect depend upon that which group is attached. Releasing groups or electron pushing groups are attached as shown, then they will show plus I effect. If electron withdrawing groups are attached, then they will show minus I effect. Electromeric effect is a type of temporary electronic effect. It takes place in the compounds containing multiple bond like C double bond O, C double bond C, etc. So, you can see here itself becoming negatively charged and carbon becomes positively charged. There are two types of electromeric effect, positive electromeric effect. So, from the figure it is quite clear that one of the carbon will attract the pi electron, and if you add negative electromeric effect, in this effect the pi electrons of the multiple bond are transferred. For example, when you add nucleophiles say Cn minus, so it will go carbon because it will show repulsion there. Next is resonance, presented by two ors of the compound. All the possible structure is an intermediate of all the possible resonating structure or canonical structures called resonance. Example given here is of benzene. You find that there are double bond alternate to varies, whereas in the third structure there is a ring which shows that double bond is single bond are resonating in a. Why this happens? Because when the bond, it was observed that it was 139 picometer which was intermediate between C single bond C bond length which was 154 picometer and C double bond C bond length which was 130 picometer. So, it was considered that this particular molecule shows a resonance. Another example could be taken of ethyl H on effect. You can see it from the figure. Now, let us understand the types of reaction. There are four types: substitution reactions, addition reactions, elimination reaction, and molecular rearrangement. Nucleophilic substitution reactions. In nucleophilic substitution reaction, one of the atom in an alkyl group is substituted by a nucleophile. For example, here alkyl halides are taken and nucleophile is attached to it. So, when you attack nucleophile, it is substituted by X, where X is a halogen. So, haloalkanes on attacking with a nucleophile will result into the formation of halogens like chlorine, fluorine, bromine, etc. In case of electrophilic substitution reaction, generally it takes place in aromatic compounds like benzene. So, here benzene is attacked by or reacted by HNO3 and H2SO4. This particular reaction is called as nitration of benzene, in which NO2 group is attacked on the benzene ring. Why electrophilic substitution takes place? Because benzene ring is already electron rich. Benzene does not undergo nucleophilic substitution reactions. Now, next is addition reaction. Addition reaction generally takes place in unsaturated hydrocarbons such as alkenes and alkynes, which are extremely reactive towards wide variety of reagents. Here the double bond is broken and the compound is added to it. For example, it is shown here, ethene is taken and you are adding bromine to it. So, double bond will be broken and Br molecule will be completely added. So, this particular reaction is called as addition reaction. Next is elimination reaction. In elimination reaction, which could be simply understood by taking an example, here we have taken an example of ethanol, in which you are eliminating a particular molecule and the product formed will be a double bonded compound. So, this is also called as dehydration, and this particular reaction is taking place in presence of certain catalyst. Next is molecular rearrangement. Molecular rearrangement proceeds with a fundamental change in the hydrocarbon skeleton of the molecule. During the reaction, an atom or a group migrates from one position to another. For example, here it is 1-chlorobutane on reaction with aluminium chloride, which acts as a Lewis acid, forms 2-chlorobutane. So, there is only a rearrangement of the atom within the molecule. Such reactions are called as molecular rearrangements. Thank you.